Hello, how is everyone?
Hi there.
Good.
Hi, Kelly. Looks like we have Kent on and Griff and Jim and Ian, and Mike, Christian. I think Ed's going to join us as well. Um, so I'll wait before we get started. All right. I don't know if he's okay. Well, let's just go ahead and get started, and we have a lot to talk about. But hopefully Ed will join because we also had some board resolutions that we wanted to mention. And let's go ahead and the technical updates are quite fun. Kent has made a lot of progress with the compiler. So talk about what you've been working on, and we can kind of go through that together.
Sure. So I guess first off, we have we cleaned up some of the tuple space some of the produce consume functions in the tuple space implementation, and then we went on and implemented the I guess the comparison and the arithmetic operations.
Yes.
On the compiler side. And yeah, I think that's the sort of major updates.
Yeah, that's exactly right. So this is all. So there are a couple of little things I want to mention, but this is all in preparation. So at the end of the month, beginning on the 26th, Kent, Joseph, Alex Balkan, and hopefully Andrew Watson and I will all be working intensively to get out a tutorial on programming in Rolang. So there we're going to get out kind of hello world examples of wallet and token contracts. So how you would write those in Rolang. And of course, for those kinds of things, you need arithmetic, and you need comparators. You need to be able to say, add this much to the existing balance, unless the balance is less than zero, or take this from the existing balance less than zero. So those are basic kinds of things that you want to be able to say, and so the syntax for those is now available inside the language, and there are a few examples that Kent has put up. In preparation for this step, I put up some work both in the Rolang spec, but also in January timeframe. I wrote down how this relates to our formal semantics. So what I showed was that you can do full faithful church numeral style encodings, and I covered not just sort of the arithmetic kinds of operations, but operations for lists and other kinds of collections. So basically, all of the built-in data types have a nice and friendly interpretation just in the core language, which is why we could write down the core language and say, that's it, that's everything. But of course, we know that that from the point of view of convenience of programming, it's not nice to do finance using church numerals. So that is why why the language needs to support some higher level expression languages, sort of mini expression languages inside the language. for those kinds of computations and calculations. Now, what makes this really interesting, just from a language design perspective, is that because processes are first class, so that means that processes can be passed around and processes can be stored and these kinds of things. It makes it easier to then say that values are processes. So in particular, you can say things like true, the number one, or the string hello world. Those are all values, and because of the way Rolang works, they end up being processes, and so we have a natural way to provide the common the sort of common arithmetic syntax, which is a little bit harder in other kinds of approaches. The way I like to think about it is because of the reflective character, we have a relationship. We have sort of the multi-set ends up being the data structure for Rolang, like the list is the data structure for Lisp. Or scheme or those kinds of functions. And we sort of have the same kind of natural data program relationship inside Rolang. And the ease with which Kent has been able to put that in is both a testament to Kent and his skills and native intelligence, but also to the cleanliness of the semantics. So I heartily encourage everyone to go and take a look at that. And along the lines of semantics, we also had a couple of nice blog posts that Mike put up on the In Category Cafe. And Mike, I was wondering if you wanted to talk a little bit about those, since that relates to the typing system for Rolang.
Sure. So we wrote up those two papers and put them on the archive, and that garnered some interest from John Baez at the In Category Cafe. So I wrote up one post that introduced the concept of a graph-enriched Levere theory. For programmers, a Levere theory is very similar to an interface for a class. That is, it gives the API, but not any of the implementation details. Together with axioms that any implementation has to satisfy. So then an implementation of that would consist of code for the methods and so on, together with proofs that the code satisfied those axioms. In most programming languages, people will try to substitute tests for proofs, but this is a very mathematical thing, so we stick with proofs. So graph-enriched Levere theory captures the basic data that goes into describing a term calculus. So the first thing that you need in order to describe how a computer computes is what the state of the computer looks like. If you're doing a simple computation model like lambda calculus, the entire state of the computer is just the lambda term. If you're doing computation on a Turing machine, however, you have the state of the tape, you have the transition table that shows how writing a cell here, if you're pointing at this cell here, then if it's a 0, you move to the left. You change it to a 1 and move to the right. Or if it's a 1, then you do whatever, right? The transition table of the Turing machine. Also the current state of the Turing machine and the position of the read-write head on the tape. So all of that stuff has to go into the description of the current state of the Turing machine. Real programming languages have immensely more complicated states. In JavaScript, you've got two different stacks, a heap, and a whole bunch of other stuff that goes in there into describing the state. So for each different piece of the state, you'll have what's called a sort that represents that piece. The next chunk of data you need is how to build up each chunk. So in lambda calculus, you'll start with variables. So you'll have one sort for variables, and then you build up terms by application and abstraction. So there are these term constructors that you describe. Next, there are equations on the term constructors. So that tells what kind of structure that is written down in the syntax we want to ignore. For example, if we're writing a function f of x equals x squared, that's really the same function as f of y equals y squared. We don't care which variable is used. It's a dummy variable. Similarly, in row calculus, we don't care about the order in which processes are written down in the term, because they're all running in parallel. There's no implicit order on these processes. So writing down equations that express what kind of structure we want to ignore is the third piece. The fourth piece is the reduction rules. In lambda calculus, that's beta reduction. In row calculus, that's the synchronization and communication rule. And finally, there's
virtual machine. That's the transition.
Yes, that's the transition function for a virtual machine. And finally, there's the set of contexts in which reductions can happen. In most modern functional programming languages, even if you have t reducing to t prime, some term, some state of the computer, t reducing to t prime, you don't want lambda x dot t to reduce to lambda x dot t prime. In Haskell literature, that's called weak head normal form, that you don't reduce anything underneath a lambda. So all of that data is captured in this notion of a graph-enriched Lebesgue theory. So that was what the first post was about. The second post was about how we can use reflection, which is the R in row calculus, to make reasoning about the operational semantics easier. It turns out that reasoning about languages with binders in it is hard. In 2005, there was a set of challenge problems on representing binders called the Poppelmark challenge. But the original approach to reasoning about languages with binders was to eliminate them using some kind of homomorphism of calculi. So in the case of lambda calculus, to get rid of the lambda binder, you translate it into SKI calculus, where they're just these three combinators, and you can express every lambda term in terms of those. And so that result had been known since the 30s, that you could do this abstraction elimination. When Milner proposed the pi calculus in 1990, people started trying to do something similar. Yoshida in 1995 was able to get rid of binders coming from an input prefix, so the for construction in Rolang. But she wasn't able to get rid of the new names, the bound names coming from the new operator. Greg and Matthias Radestock, Matthias or Matthias? Anyway.
Matthias,
thank you. Matthias Radestock showed how to use quoting and dereference operators to eliminate the use of new in the pi calculus. And in their paper that described the row calculus from which row lang is derived. And so then in our papers, we used that technique in two different ways on PyCalculus. One using the Yoshida style abstraction, and another one using SKI style abstraction elimination. And so I described the resulting theories there. So that's a summary of the lead up work we're doing. The resulting graph-enriched Levier theories capture the operational semantics, and then you can use those to, in applicative calculi like lambda calculus and SKI, you can throw away some information and recover the denotational semantics. That is, that individual terms can be modeled by functions. In concurrent calculi like row calculus and PyCalculus, the evolution is of course non-deterministic, so you can't model them directly by functions. And this gives us a roadmap for how to approach the denotational semantics of these concurrent calculi.
If I could ask really quick, Mike,
yeah.
what's specific about the quoting and dereference operators that makes that possible?
It's the fact that new can be thought of as splitting up into two parts. One of them is very much like an input in that it's declaring a new scope under which a name is bound. And the other part is providing a fresh name. So new can be represented as input a fresh name from some process that produces them, and then evaluate this term in that context. And that's precisely what Greg's transformation does, is come up, I mean, it's parametric in two processes, one of which defines a namespace, and the other one produces a fresh name in that namespace. So as you recurse downward through the structure of the term, it's defining a namespace for each substructure of the term, and then defining a new fresh name in that namespace so that it's guaranteed to be fresh in that scope.
Actually, first of all, I want to say that was a remarkably succinct and clear description. Thanks, Mike. That was really, you did it better than I did.
Thank you. But I just wanted to point out, ambient calculus does not have input prefixes. There's an extension to the ambient calculus that does, but the pure ambient calculus without that doesn't have prefixes. And so that makes it very hard to use reflection to do this trick. Greg had to come up with an entirely different approach to ambients to get a representation of them in row calculus, using namespaces for the ambients rather than just the standard reflection that he used to get row calculus from Pi.
Yeah, and actually it was quite interesting there. Still does direct encoding of the ambient calculus into Pi. So showing that the ambient calculus is considerably more expressive than Pi calculus. The ambient calculus is like at the other end of the spectrum. It's too expressive. One thing that is worth mentioning also, just as a quick extension to Mike's comments, when Matthias and I were doing this work, Matthias was sort of exploring an obvious solution, which is that once we knew we had this trick, then there are essentially there's a bifurcation in the approaches. One is you have a fresh name server. So this is kind of a runtime approach. When you need a fresh and the fresh name server will pony up a fresh name for you. And even in 2002, when I was carrying out this work, I didn't like that approach because it's centralized. And I was already aiming for decentralized solutions. So the solution that I came up with in the paper is a compile time solution, which is decentralized. So there is no is ponying up these fresh names. It happens as a result of a compilation of the pi term. So you compile it into a row calculus term, and as a part of the process of the row calculus, the compilation to row calculus, you get this decentralized fresh name idea, and that turns out to be quite powerful. And it's almost like the future was reaching back into my mind and saying, you're going to need this decentralized stuff soon. So that's that is one of the one of the subtleties there. There's another subtlety which is super mathematical, so I won't go into it. But for those out there who are interested, there's a connection between fresh names and Galois extensions. So there's a third solution, and the other way to think about it is that it's related to being able to have recursively defined names. So the grammar for the row calculus does not allow for there to be infinitary names. All the names have finite information in them. But you can provide recursive limit points. And there's a perfectly consistent calculus that's representable in a computer that has a recursive, and that gives you yet a third approach to eliminating new. I haven't written up that approach, so if there's any summer interns out there who want to work on that particular extension, we're always up for folks who are interested in that kind of stuff, engaging with folks that way. Thank you, Mike. That was fantastic. So is Ed on? I don't know.
Yeah, I'm here.
All right. Well, let's move on to from the technical stuff to a little bit of the business stuff, and then come back to some other technical updates.
Oh yeah. So I got a few things to update on. Yeah. First thing is actually a question for Kent or Greg on the math in Rolang. It was. I'll tell a little story. It's like so Lisa, our CFO, was working on balancing out some of the historic AMP and Bitcoin transactions for co-op, and noticed that Excel didn't add up correctly when it went down to 8 digits of precision. And actually what happened is Excel and Google Sheet use floating point math, which only handles 15 significant digits. So it was, of course, that for CFO types that like to balance to the penny, this was driving her nuts. And so for me, after I realized the problem, I thought, just round it. She's like, no, I can't do that. So my question is,
for a while, IBM was involved in the ECMAScript standardization committee for ES4. And the only thing they wanted, the one and only feature, and all of their support was focused on give us decimal number types.
Yeah. So either fixed point precision or anyway, we have to make sure that we handle many significant digits in the world.
I'm so glad you. So we're doing this in stages. We're not. Just a quick.
Your audio is cutting out.
Can you hear me?
Your audio's been cutting out all call. No one else's has.
That's weird. I wonder what's going on.
It's been happening actually.
Let me see what's going on.
Probably
Let me try.
player.
Greg, it's like this every time when we're in one of these Zoom meetings. So it's unlikely that you'll be able to fix it right
Yeah,
now.
it happens in Skype occasionally too, I believe.
Hang
Anyway,
on. I just
Greg,
switched.
you have to reboot your machine, Greg. The simple solution, reboot your machine.
Yeah, I'm not sure. Actually, can you? Am I cutting out now? Can you hear me?
okay now.
It's
Okay,
cutting in,
great.
fading in and out, very frequently, Greg. I mean, every time you talk, you sound for 2 seconds and then it goes out for 2 seconds.
Okay. Well, is it better now? Can you hear me now?
At the moment.
Yes. Okay, cool. So what I just did was I switched from my to the 5 on the network provided by Comcast. So I think it may be a network issue with the 2. This machine is just far enough away from the modem that I usually have it on the 2 rather than the 5. But I just switched to the 5 and that seems to be better. So has it stayed
good so far?
All right, awesome. So it seems like it was a networking issue. So I just wanted to mention briefly, we're doing the language in stages, right? We're we start with a core that we well understand, and then we make extensions. So the extensions for the numeric types right now are just the numeric types that are easily supported in Java. And so we're going to be stuck with those limitations. However, one of the little pieces of brain candy that I put in the church numeral paper for Rolang is that we can not only do infinite precision, we can do one better. There's a clean encoding of Conway's surreal numbers into Rolang. Now, I'm not claiming that would be computationally efficient, but we can be infinitesimally precise.
Oh, cool.
So anyway, back to you.
No, that's awesome. That's good to hear. Yeah. So I'm going to jump around on different topics. As Greg reviewed last week, we worked on a document around the supply of the staking tokens, and I'll paste the link here in Slack if I can find the right place. Where is it hiding? There it is, or in the Zoom rather. So that's the document, and one of the reasons that's important is for new investors that we're talking to want to really understand, the either the amount of rock they may get, or certainly the amount of rocks that RChain Holdings holds, and what its future utility is relative, or the conversion into Rev, what that future utility is relative to other staking tokens that might be produced. And we talked about that last week, and so but anyway, so we're going to have a board resolution from the cooperative so that they have as much comfort as we can provide in that in their decision. Let's see. So yeah, a number of investors have been approaching Greg and me, often separately, sometimes together, and we're actively following up with those conversations. We are continuing to have fundraiser pitches and feedback. We have another session this afternoon. And those are going quite well. As you all know, it takes a while to explain, depending on who the investor is and what their comfort level is with crypto and so forth. So that we have to be a little bit fluid in how we present, based on their background, but also just where the conversation goes, because the surface area to cover is so large. We had a good financial planning session, Lisa, Greg, and Navneet and myself earlier this week, Monday I think that was, where we talked about the staffing forecast of the co-op, growing the team to about 20 for the development, and then a few more. Those would be as many contractors as possible versus employees. Is kind of the mix, and that would allow, if I remember, Greg, about 4 or 5 on each of the teams for storage, for comms, for the virtual machine layer, and for system contracts. I may not have that quite perfect, but that's roughly the shape of it.
Yeah, that's roughly the shape of it, and things will morph over time, right? Like comms and storage are fairly well contained efforts, and so once those are nailed down, they're nailed down, and so if people want to be moving upward to working on system level contracts, or they want to try their hand at some of the finer details of language design or compiler work, or they want to get into the consensus stuff, the Casper stuff, there is more than enough work, and it's rich, interesting, and good technical work. So let's go ahead and put that out there. So right now, Nash and Kelly and Mike are they're with Pyrofex, and Pyrofex is handling our staffing. So if there are developers out there, we kind of have to hit the ground running. As soon as the major bulk of the first tranche hits the bank accounts, we need to be rolling. So we need developers, in interviewing right away. So if you're out there, you're interested in cryptocurrency, you're interested in language design, you're interested in consensus. These are all tough, interesting, fascinating problems.
Yeah, and either a desire and aptitude to learn formal methods and functional programming is part of that whole mix.
Yeah, concurrency theory, absolutely.
Yeah. Awesome. So can I continue?
Please.
All right, cool. So obviously on the financial planning side, that there's more to do. The considerations around tax are really interesting. how and when money moves. Interesting and maddening at the same time. How the assets are deployed in the various cryptocurrencies and U.S. dollars. So that's an interesting topic as well. So that's moving ahead. And then wanted to mention also, I've mentioned this every week, but we're continuing our exploration on identity-related things. Glenn and I, Glenn's on the call here, participated in the co-op's Bring Your Own Identity session that Jim Weisgarber's been leading. So that was Saturday morning, and at least I think Glenn will be continuing to attend those, and I'll attend occasionally. So those are great conversations. On the holding side, we're looking at this intersection of identity, of wallets, and browser kind of interactions. And so, for example, I looked at Uport this week and kind of understood how that was working. Other things that happened I guess it was maybe 2 weeks ago already. The Brave browser, raised 35 million in an ICO in 10 minutes. Civic, just 2 days ago, or maybe it was yesterday, $33 million. Most of it was sold even before the ICO happened. So it was essentially instantly committed. So these are all kinds of similar plays where Brave and Civic are working, that the user can own and manage their identity and growing it. I assume their strategy is to grow into a more rich self-sovereign identity. But also, for micropayments, or for those to reduce the barriers and frictions between a content producer and the consumer, so that there's removing all the middlemen and leeches along the way, so that those that are consuming content can get that. Pay for that content and benefit directly to the producer. So that's kind of common theme of these things, as well as the attention economy features that we ultimately want to build. So
Ed, really quick, just a slight commentary on the attention economy. And Greg, a question for you. When did you first publish the paper on the attention economy?
So the concept of attention economy actually, wasn't invented by Scenario or Greg. Others, had that term and that concept out there, not necessarily related to crypto. But
Oh yeah, the notion of attention economy it goes way well back. I remember reading popular press articles about attention economy in 2007 and 2008. So people were a lot of people noticed that the social media constituted sort of a first mechanization or realization of the idea of attention economy, or some of the key characteristics of attention economy. So yeah, that notion goes way back. Now, the specific details of how this relates to cryptocurrency, how this relates to microtransactions, and these kinds of things. Those were obviously much later in the game.
Yeah. So well, my point in asking was more so on like the peer-to-peer content delivery and marketing side was, especially in the past couple of years, there's been an absolute explosion of entities that are leveraging the peer-to-peer marketing idea to further their own brands. And I thought it was really, really cool that now the industry so well corresponds with what the attention economy was essentially built for.
Exactly. And once micropayments become more and more practical on the blockchain with RChain, then the world's going to change, frankly.
Exactly. Yeah.
So just getting back to my status, let me finish up the status and then hand it back to Greg. So the other thing is we have a Medium article that's been written introducing RChain. Shin Guy Thornton has written that, and he's going to get that posted via CoinFund's site in the near future, which is great. It's going to get a lot of eyeballs on it. And then also, Nathan, are you there? And do you want to give an update on the animated video?
Yeah, the animated video is in it's almost totally complete. We have the full video. We're just going to edit a bit of the animation itself, and then also get feedback internally about it, so that we can go forward in making other ones to address different communities, both developer and non-developer, and then investors. And then lastly, about in that zone is we're also in the middle of figuring out the branding document, the colors that we're going to use, the token logo, and basically all things sort of branding, which we did not have going into the video. So that's the update.
Awesome. Thanks, Nathan. Back to you, Greg.
Thanks, Ed.
You're welcome.
We need to. I need to have a big, world map behind me.
Weather at 5.
That's right. Exactly. So a few other updates. Part of the meeting with Lisa was also to go over her proposal to take on an acting CFO role with the co-op, so we've kind of shaken hands on that, so that'll be good because I've got a lot going, a lot on my plate when it comes to just managing the business part, and I'd really like to shuffle that off, trying to get even just getting the house in order so I can hand over a big chunk of the functions to Lisa and HJ has been very, very time consuming. Just the big run up on Bitcoin and other cryptocurrency has made it really, really hard to do certain functions with respect to AMPS and the Omni platform. So that's been incredibly time consuming. So I'm grateful to get some help on that. Let's see. I also wanted to mention that we're now, Mike and I, sort of as a culmination of some of the work that Mike and I have been doing, we're now moving over into the prototyping stage for the ladle algorithm. So we've gotten it to the point that we're satisfied that the mathematics hangs together. And so we're now making decisions about the platform for the prototyping of the typing algorithm. and look forward to seeing those commits to the repo in the not too distant future. I'm super excited about that. I'm really, really excited. This is, you know, I don't know how to say it. This is, well, let me put it this way. When we had a really nice investor meeting with some of the folks from Auto Capital on Friday, kind of an in-depth presentation, and mostly we were just focusing on RChain and the crypto applications and these kinds of things. But it came to light, you know, so we turned the conversation turned towards the formal methods, and we mentioned the ladle algorithm, and then I just, you know, offhandedly pointed out that once you have a rich typing mechanism like this, it becomes a query mechanism. And their eyes got wide. And the way to understand this is think about the language I use sometimes is that code is kind of the dark matter of the internet. And what do I mean by that? Well, what I mean is that it's a huge data asset, right? If you think about GitHub has what, terabytes of data, maybe petabytes of data up in there, and a big chunk of that is code, and yet it's impossible to search that code on the basis of what it does. Right? You have to search that code either because someone else knows the code base, so you search it socially, or you search it on the basis of some kind of metadata or annotations, which are also often completely either misleading or unsatisfying. But if you could search it on the basis of what it does, that would make it more like a data asset. Now, if you think about it, GitHub is just the code that's public, plus some code that's private, but it's mostly public assets. Behind the firewall, there's a bunch of code in the enterprises, and that's also a data asset that's completely unsearchable, right? All of that is searched on the basis of social. It's searched on somebody who knows somebody who knows somebody. If you could search that code just on the basis of what it does, then suddenly that code as a data asset would be many times more valuable. So the ladle algorithm gives us a mechanism to search code on the basis of what it does. Now, if you think about the revolution that's taking place with respect to contracts and smart contracts, this is not only recovering the value of things from the past, which have been undervalued and underutilized. It's also pointing us towards the future, because if RChain succeeds, or even if Ethereum succeeds, proliferation of contracts, just like there's been a proliferation of JavaScript programs and Java programs and C# programs and so on and so forth. So there's going to be a proliferation of Solidity programs, and there's going to be a proliferation of Rolang programs. And now what you want to do, especially when we're talking about financial models, is you want to be able to manage those models, not just the data that they work on, but manage the models themselves as if they were data assets. And so you want to be able to say, remember that contract that we used to model derivatives in this way, right? I can't remember the name of it. I don't even remember who did it, right? That's the sort of a scenario we can picture in our minds. But if you could write down a little type-based description of that model, so you sketch out roughly what it did, then you can actually ask the system to go and search for that contract. And so when we describe some of these potentials of just the ladle algorithm alone, the investors got quite interested and quite excited, because they hadn't seen that angle. The sort of yet another dimension to what we're doing with RChain and Rolang and the ladle algorithm. So that's why I'm very, very excited to be reaching this point where after almost a decade of research just on the type part of this. We're getting to the point where we're prototyping, and that will be folded into the Rolang repo in the upcoming months. So it's very, very exciting for me personally, but also I think in terms of the overall offering. And I really, you should allow your imaginations to run for a bit on this. Think about discovery protocols based upon typing information. So piecing together contracts just in time, right? That's another example of the kind of thing that you can do as a result of having the ladle algorithm in operation. I think Mike and Nash have thought about a souped up cloud-based linker. How did you describe it, Mike?
Well, the idea was that if you can prove properties of a code base, say, some subset of the programs on GitHub, then when you do your query to GitHub, you can get all of the code that satisfies the property you're looking for. What it means is that you can get a new monetization model for open source software, where an open source developer opts in to allowing his code to be linked in response to one of these queries. And so the linker service gets a cut, the open source author gets a cut, and the guy who links it in pays for the privilege.
Yeah, that's a beautiful, beautiful model, and it's enabled not just by the microcurrency capabilities of the blockchain, but it's critically enabled by the ladle algorithm, right? It's only if you can search on the basis of what the code does that you have that this starts to make more sense.
Exactly.
Yeah. So that's why we're super excited about that. Let's see. Any other updates that I can think of? I think I'm.
Hey Greg, I have something real quick I need to bring to your attention. I need
Yes.
to take it offline between you and Ed though. I can do it in Slack. I just need to. Yeah, it's pretty important. It can be pretty major. Maybe not. So but I didn't want to take it here. Anyways, keep going.
Oh yeah, no, that's cool. That's cool. Yeah, sure. If Ed, do you have time right after the call?
Yeah, a little bit.
Okay, cool. Let's do that. Trying to think if there's anything else. I mean, for me, that's a lot.
I have a few updates, Greg.
Yeah. Go for it.
So yeah. So as you know, I'm searching for activists to do some side work on the RChain cooperation, and there's now 58 people registered, and 40 people are actively involved on the GitHub RChain members repository. There we collaborate together. But there's also some bad news. These people got registered through Google Forms, and the answers of the Google Forms are in spreadsheets, and one of those spreadsheets was publicly exposed. So with some sensitive data, that means more than email addresses. So I'm going to ask Evan what to do about this, because this is a leakage of personal information.
Yeah, I saw that. Yeah, so I'm glad it was brought to our attention, and that we're taking steps to rectify the situation. I understand that the page has been given different permissions, so that's a step. We can probably also figure out exactly sort of the level of traffic there, and see if it was how far and wide that might have spread.
Yeah.
There was a post to the RChain Slack on April 13th, bringing this to the attention of the community. So it's been publicly available at least April, May, and June.
I don't think that's the case. I'm pretty sure I checked permission after that April comment, and it was tightened for a while at least.
Yeah, that's true, because the permissions went on and off. So that's because of this Google Forms and, well, giving access to it, and it goes pretty easy. And that's a kind of failure, in fact. But all documents are now checked, and only certain people have access.
But the fact that it happened twice is kind of concerning. It seems like we need to have somebody involved in checking and maintaining these things, setting up policies, setting up procedures so that that can't happen again, things like that.
Yeah.
Chief privacy officer or something like that.
Yeah.
Yeah, it's a good idea. It's a good idea. Agreed.
Okay.
Anything else, HJ?
Yeah, the co-op bylaws also require that the board pass a privacy policy, which we haven't done yet.
I'd like to welcome Joseph to the group. I had a talk with him yesterday. He's very excited. He wants to do something useful, has a lot to learn, maybe in the noobs group. Tomorrow we have people wanting to run Rosette and run Scala IDE, and need a little help, and we'll unless somebody steps up to coach, that's what we'll be doing tomorrow at 1 o'clock New York time.
Interim SJ, I think what we can do, we can pair up checking, until we have this new person or, people of person. I think, can we put 2 more people as a verification, anything we are doing, at least they can look into the data and check the permissions.
Permission.
No, so what I'm proposing to SJ is at least SJ asks 2 more people to look, we shouldn't be anyway doing that exposing Excel kind of thing, but at least look, to the permissions by 2 more people, not only you, and, ask to verify 2 more people so that the permissions are correct. They are not public, open, and
Are you talking about the Mattermost?
No. I'm talking in general document permissions where there is a sensitive information.
Right, and I always make sure when I go in a document that has sensitive information that the permissions are right. I didn't notice the issues that we have.
I can give an update on what I've been working on in these last few minutes. Cool. All right. So the last time we spoke, I think publicly about this, the route that we were pursuing was attaching weights essentially to each of the grammar constructs for Rolang. And what we kind of always knew, and what we definitely found out, or what we've definitely been seeing, is that on top of the typical information such as input size and such as method invocation that we cannot know statically at compile time, we're also dealing with non-determinism that's present just in the semantics of the language. So my thinking this past week has been kind of a step beyond that, and essentially, the idea is that if we have a dynamic mechanism, then we can always get the actual cost of a program if it's dynamic. If we have a static mechanism, then the best we can do is the maximum, an upper bound on the cost of computation. And as a small example, that's done typically. There are two types of non-determinism. One, when you have two output terms sending to one input term, and you don't know which message is going to be received first. So in that case, we would be forced to take an upper bound on the largest input size and the length of the process of the continuation with that input, and then the other with the other message. So we take one out of those two paths. And then the other case of non-determinism, of course, when you have a message being sent on one channel and there are two input terms waiting to receive it, and you don't know which is going to receive. And again, we take max bounds on that term. But since we can always get a cost dynamically, that method should take precedence. Developing that method. And actually, it's pretty interesting. I'll explain in a moment, but we find an overlap in what are static versus dynamic cost analysis. They kind of require each other. So given that when we run a program dynamically, we're going to have a set amount of rev, and every action that we take through the course of that program is going to decrement the amount of rev that we have by a certain amount, which that action is assigned by the weight. And then the question is, if I have a set amount of rev, and I have three processes that are executing in parallel, how can I guarantee that all operations against rev are valid? Well, there are two courses, at least initially, that I identified, and one is to make rev a global value, which is a bad idea for a number of reasons, for performance and for sake of accuracy. And that the second is actually to make the cost analysis statically by max bound, and then associate that max possible cost with each process, and then use that as the amount that we're deducting from dynamically, with the difference being the refund that we get. So dynamically, we can think of P, or any process, as a sequence of actions represented in bytecode. And each of those are going to affect some state of the machine in some way. Most of those will be internal, unobservable, and they're just going to, whatever you can think of a bytecode doing. And essentially, we want to say that if any point you reach a rev amount that is less than or equal to 0, we want to halt the machine, insufficient rev. But of course, we also want our cost analysis to be consistent with the operational semantics, structural congruences, and bisimilarity of the formal model. So from perspective of bisimilarity, we want to say that if two processes can execute on top of course, our normal requirements for bisimilarity, if they can execute with the same amount of rev and both reach a stable halting state, which implies obviously that rev is not equal to, not less than 0, then they are weakly bisimilar. And we obviously, we can't say that they are strongly bisimilar because we don't know exactly, because they could take different unobservable actions that ultimately cause the same, that have the same effect on the environment that's unobservable to whatever witness or to the environment.
Well, hang on. So you folded into your idea that they do the IO matching, right? So when you were saying on top of the additional requirements of bisimulation, so that's where you're tacking in that they do the IO matching, right?
Of course, yeah, definitely.
Okay, all right, sorry. Yeah, took me a minute to parse what you were saying there. Got it.
Sorry about that.
No.
Well then, the next question then was, how do we synchronize essentially two processes? How do we actually, transition the system? And generally, the general idea is that, considering we have P par Q, output par input goes to Q prime, or Q with bound input, that the system will transition with the rev left after performing the input action, and all of course, the remaining rev in P and the remaining rev up to Q. And when it transitions, it's going to copy the remaining amount of rev into the amount of rev that Q witnesses. And then Q, the continuation, executes with that amount.
I understand. So you're looking at the problem of how to decrement the rev as it's executing.
Yes.
Okay.
Yeah.
Okay. Yeah. So I wasn't quite. I wasn't able to follow exactly. So yes, that's an additional piece of the puzzle. So in addition to estimating the cost up front,
Mm-hmm.
Which is a map from the contract to a decorated contract.
Mm-hmm.
We also want to look at the other side. When a contract is executing and has a certain amount of rev, what's the throttle?
Right. Like how far can it go, but without reaching, without running out?
Yeah, exactly. Or yeah.
So
Or what,
I understand that you will have the lower ceiling and then lower bounds and upper bounds. I'm not sure what you guys are, talking in that sense, right?
no. What Joseph is saying is you need to be able to provide a. I'm paraphrasing, and so if I've gotten it wrong, please just jump in. So I'm just going to echo back what I'm hearing. And I also want to be a little bit more precise. We're not talking about rev. We're really talking about phlogiston.
Sorry, phlogiston. Sorry,
Yeah.
my fault.
No. That's totally understandable. So a party, an agent that wishes to execute a contract on the row VM supplies a certain amount of rev in order to get phlogiston. The question is, how much rev should they provide? And then once they, and then the next question is, once they've provided that rev, as the contract executes and uses up phlogiston, how is the phlogiston used up? And how does that relate to the decrement of the rev that was supplied?
Sorry. Well, anytime I said rev, please pretend I was saying phlogiston. What I meant was essentially throughout the execution of a process P, any action that's internal to that is going to decrement the amount of phlogiston that we got, because you're affecting the state of the machine essentially, and in some way. Whether that's whether you're increasing the amount of memory that you're using, whether you're executing, say, an instruction which has a cost, so either data or compute. So we want to get kind of an idea of how much we're going to consume throughout the lifetime of the contract. So statically, at compile time, we can take the maximum, like whatever the worst case scenario is that takes the most amount of phlogiston throughout the entire execution. And then we're going to require that they pay that amount before it's executed. That amount, that max, is then going to be used as our metric dynamically. That's going to be used as the amount that we start with dynamically. So in that way, we always have enough phlogiston, in the worst possible scenario to finish. But if they overpay, if say we don't run at worst case scenario, then we're going to get a refund on the amount of phlogiston that you gave us in rev.
Joe, I want to step back.
Yeah.
I'm not sure why you are including a term dynamic, right? So if you're already setting up a upper bound and lower bound, so let me step back further. So somebody attached certain amount of rev with your contract to be executed in future date, whatever.
Mm-hmm.
There'll be a conversion between rev and phlogistons, right? There'll be some mechanics how they can get certain amount of phlogistons that will be applicable to get the computation, storage, and network, all three things together, right?
Sure, yeah.
And I'm not sure how you dynamically changing, because before you put your contract into the network, I would imagine you'll have a fixed rate for these things, which may change with time. But when you're signing a contract, that amount should remain same.
What he's saying is that as the contract executes, so let's consider a very simple contract, right? So like the Hello World contract. In the Hello World contract, the contract waits on the channel world 1 for a message. Now, in order to run that contract, the agent that submitted the contract for execution needs to supply some rev. When they supply, let's say they, just for purposes of discussion, they supply 10 rev, right? And for that rev, they get so much phlogiston. We're able to provide so much phlogiston. Now, if they have provided a sufficient amount of rev for a sufficient amount of phlogiston, they can actually perform the read on the channel world 1. If they have not provided sufficient rev, then that read can't be performed. So imagine that the message is a 1 terabyte video, right? And they've only provided this 10 rev, and so as a result, they don't have very much phlogiston, so they can't actually perform the data operation associated with the read, right?
Agreed.
And so what should happen is that the contract. Hang on, let me just finish for the purpose of the audience that might listen later. So what should happen is they'll get an out of phlogiston error, like a Ethereum out of gas error, right? And then the contract will roll back in the sense that any data that was read from the channel partially, it will be as if it had never been read, and another contract potentially could pick up that data and consume it for itself. Now, if they
that sounds bad.
Well,
if you can partially read information, you can leak something in there.
No, you can't. The problem, no, it's a lot safer than it sounds, because the contract can't have the read things are partial. I mean, atomic, not partial. So if the read doesn't happen, then the continuation doesn't ever get a chance to execute.
Okay.
Exactly.
So, Greg,
so let me just complete the picture, and then we can jump in with lively debate. Now, suppose that that the amount of data that was read was much smaller than what was allotted for in the phlogiston that was associated to the contract. So the read succeeds. So the message is read from the channel, and now you can move on to the continuation. But at that point, the continuation should not have the same supply of phlogiston. It has to have a supply of phlogiston that is decremented by the action, the amount that's associated with the action of reading. And that's what Joseph is talking about.
So I see, theoretical challenge with this whole theory. Number one, you are already defining upper bounds and lower bounds for, how much it's going to cost. And my estimation that when you're costing it, then you shouldn't be talking
just upper bounds, not lower bounds.
Agreed.
Okay.
So now another example, you gave 1 terabyte. So my expectation would be when you are floating a contract or pushing a contract into raw VM, you will give them the estimate and you charge, upfront. And that's one way, unless until you define a contract which would have dynamic charging capabilities where, VM would charge that contract dynamically, right? I mean, there are 2 separate kind of contract we are talking about.
No, we're not talking about. We're not talking about.
Let's kind of make a distinction. I guess first it would be really helpful if, and I guess I assumed it, but reading the Ethereum documentation on exactly how their gas pricing works would be really useful. Right now, their entire approach is dynamic. It's as the contract is run, with every action, every bytecode that's executed, we decrement the amount of gas by a certain amount. So what I'm saying is, it's simply that because we don't know precisely the amount of phlogiston that's going to be consumed at actual runtime, because there are just things that we cannot know, we take a max bound, an upper bound statically, and we charge that up front. And then at runtime, we decrement from that amount per action that is executed on the machine. And then the remaining amount is refunded or given as, and partially, I think, the remaining amount is refunded if, in fact, it doesn't require the entire amount of phlogiston that was given up front.
So
Yes.
another way of stating this is the compiler figures out a deposit that you have to make, a safety
Yes.
deposit. You make the safety deposit, you run your program, and then you get whatever part of the deposit back that wasn't consumed by the program.
That's correct.
Yes, exactly. Does that make sense, Navneet?
No, I mean, in theoretical sense, yes, that's one way. But I think we have already muddied the water with dynamic content, right? So suppose you don't know the size of the read operations later on, right? In that case, how would you do that? I mean, that's supposing in the beginning,
know the size of the reads.
Two different kind of contracts. Where one would be the fixed pricing, second would be the dynamic pricing, right?
No, it's not
mixing both of them together.
I think that's a misunderstanding. We're not talking about. There's no dynamic pricing here. What we're talking
the dynamism is
no. The dynamism comes from just decrementing the rev that's being consumed. Sorry, the phlogiston that's being consumed while the contract executes. That's the only form of dynamism. The pricing itself, the dynamics of the pricing is a market thing, right? The dynamics of decrementing the rev has to do with allowing the contract to execute. As the contract is executing, the pricing is not being adjusted as the contract is executing. The only thing that's being adjusted is how much phlogiston has been consumed in executing each statement.
How would the estimates not be almost infinite? So if it depends on the size of an input, which could be infinite, I'm thinking, would the estimates come out as so high that it would be impractical?
See, that's
a good question.
That's an excellent question.
Yeah. So in general, think about it from the point of view of the Java virtual machine, right? So even though the list is infinite, is potentially infinite in length, the pointer to the head of the list is not. So you know that the read operation on reading a list is bounded initially by getting that first pointer. And then the exploration of the remainder of the list corresponds to additional read operations. So that's where you can look at reasonable upper bounds. Does that make sense?
I mean, conceptually, I understand, Greg. I think, my confusion started when, I think one of the statement I heard, dynamically calculations of the phlogistons. I think conceptually, I understand how this is going to work. I mean, I don't have any confusion anywhere. So I think it's much more implementation detail with how we are going to achieve these things in RChain. That's where my confusion came. Otherwise, I think I'm good. Thank you.
Well, imagine that your rev, that the amount of rev that you have is contained in a register. So it's easily accessible and very quick to decrement. And then with every action that we execute, it be just like decrementing any other value or incrementing the instruction pointer.
Yep. That's right.
Phlogiston?
Yeah.
I'm sorry. My question with respect to RChain would be, suppose your contract does 10 reads and you had spent 10 revs and it completed 9 of them, but the 10th one it couldn't complete. Now you would get a out of phlogiston error, but those 9 reads were already done, so you don't have to restart the whole contract, or
no. Well, in the case that you do run out of phlogiston during runtime, then the machine would recognize halting condition, so it would stop and then it would roll back all the changes that had been performed. That's one of the benefits that we get for free, by the consensus mechanism, is that we have a guaranteed past history of state. So, pretend like none of this ever happened in the case that you run out of phlogiston at runtime.
Yeah, and Jim, I mean, you raise a really good point that's related to long-running transactions, long computations, and checkpoints. So the benefit of Erlang is that it allows you to organize your computation in such a way that if you know it's reasonable to commit without having to read all 10 of them, then you can do that. You can write code that is aware of that versus code that needs all 10 of them in order to commit. So the transactional nature or the transactional semantics of the for comprehension allows you to set your boundaries exactly as you want. So that for example, if there are 10 parallel reads from 10 parallel channels, you could write that as a join in a for comprehension, and then all of those have to go, or the continuation doesn't happen at all. Alternatively, you can arrange your contract in a different way, and there's several different options within the language, so that you can have partial commits, right? And allow for a resumption of a state even if you get an out of gas error. So that gives you a considerable leeway within the language to be aware of the fact that there's a correlation between resource consumption and transactional boundaries. So that's a really good point you raised, and one that I think is a particular strength for Erlang and RChain. Yeah, very, very good. Okay, we're way over. I know Christian wanted to chat. I'm totally. I think it's great. This is great conversation. Let's continue to have this conversation. I need to jump off, but I also want to mention to the community so no one is surprised. I'm getting married on September 15th, the weekend of September 15th. I'm getting married, and we're going to be away for about 2 weeks from the middle of September to the end of September.
Mazel tov.
Thank you.
Congratulations, Greg.
Thank you very much.
That's awesome.
I'm very, very excited. My partner. I'll put the marriage certificate on the blockchain. But out of respect and because I'm really looking forward to it, I'm going to be away from business communications, and even though I consider many people here family, certainly friends, but we've been working together for so long, it feels more like a familial relationship. It is going to be important for me to unplug for at least a couple of weeks and then get back to things with a fresh vigor. Thank you for all the congratulations. So with that, I'm gonna bow out. Christian, do you want to meet on Skype or kick everyone off the channel and have? Okay, cool.
Christian, you want to stop it?